Hi, I hope you have practiced real numbers from the previous two videos. So today we will do some advanced questions, MCQs, short answers as well as long answers as per the reduced syllabus for March 2021. So go grab your register and before that hit the subscribe button and the bell icon.
Real numbers, class 10th. We are doing NCERT Exemplar with accordance to the reduced syllabus. So exercise 1.1, question number 4. First three questions are of Euclid's division algorithm, which is no more in the syllabus. So if the HCF of 65 and 117 is expressible in the form 65m minus 117, what is the value of m? It's a multiple choice question. So we will find the HCF on our own. So 65 is 13 into 5 and 117 is 13 into 9. So I can clearly see here that HCF is 13. But this 13 is actually equals to 65m minus 117. So this is an equation from where we can find the value of m. So 13 plus 117 is equals to 65m, or m will be equals to 130 by 65, and thus m is equals to 2. So this is the correct option. Question number 5 now. The largest number which divides 70 and 125, leaving remainders 5 and 8 respectively, is. Now they're talking about the largest number. This gives you a hint that this is talking about HCF, which divides 70 and 125, leaving remainders 5 and 8. That means 70 is not divisible. When you divide 70, 5 is left. So what is the actual number? The actual number is 70 minus 5, that is 65. And leaving the remainder 8 when 125 was divided. That means 125 minus 8, that is 117. That means these two numbers are clearly, completely divisible by which largest number. That means we are talking about the HCF of these two. And we just found it out that 65 is 13 into 5 and 117 is 13 into 9. So 13 is your answer. Question number 6. If two positive integers a and b are written as x cube y square and x y cube, where x and y are prime numbers, what is the HCF? It's simple. What is common among them? X, and if you look at y, y square. So xy square is the common factor among both. So B is your correct answer. Question number 7. If two positive integers p and q can be expressed as ab square and a cube b, where a and b are prime, then what is the LCM? What we do for LCM is we take the highest powers. Like for HCF, we took the lowest powers. So what are the highest powers here among a and a? A cube. And what is the highest power among b and b square? B square. So a cube b square is the LCM. C part. Question number 8. The product of non-zero rational and an irrational. So just an example, a rational number multiplied by irrational number. You will always get an irrational number. So the answer is A part. Question 9. The least number that is divisible by all the numbers from 1 to 10. The least number here gives you a hint that you are finding LCM. And it's like finding LCM of 2, 3, 4, 5, 6, 7, 8, 9 and 10. You can write 1 also if you want. So if I start with 2 first, so it's 1, 3, 2, 5, 3, 7, 4, 9 and 5. Now once more I can take 3 here. 1, 2, 5, 1, 7, 4 and 3 and 5. Now I can still go by 5 once again. I can see 2 factors there. So 1, 1, 2, 1, 1, 7, 4, 3 and 1. Now I see that all of them here, now 2 and 4, there's one more, they are 2 and 4. So this will be 2, 1, 1, 1, 1, 1, 7, 2, 3 and 1. So now in the last step, all the numbers are co-prime. So what is the LCM? 2 into 3 into 5 into 2 into 1 here, 1 by 1 into 7 into 2 into 3. So it is 6, 30, 32 is 60, and here 60 into 6, 7 6 is 42. So what is your answer from here? 2520. So D part is your answer. Question 10. The decimal expansion of the rational number 14587 upon 1250 will terminate after how many decimal places? So we are concerned with the denominator here because this decides. So I'll prime factorize it. So I'll start with 5. I get 5250, then 550, then 510, and then 5 twos. So in the denominator, I have got 5 raised to power 4 and 2 raised to the power only 1. So I require 3 more 2's there so that it becomes 10. So I multiply numerator and denominator. You need not go into solving of the numerator because they are not asking the exact decimal expansion. So in the denominator, you are left with 5 raised to power 4, 10 raised to power 2 raised to power 4, and that means 10 raised to the power 4, right? So how many decimal shift will be there? 4. So your answer is D, 4 decimal places. Now moving on to exercise 1.2. Question number 6. The numbers 525 and 3000 are both divisible only by 3, 5, 15, 25 and 75. Right? Both of them are divisible. What is the HCF? By definition, HCF means the highest common factor. So they have already given us the list of common factors because both of them are divisible by only 3, 5, 15, 25 and 75. The word only tells that there is no hidden factor left. These are the only common factors. So what is the highest among them? 75. So the HCF is 75. But they're asking to justify your answer. So we will find the HCF. Like 525, right? It can be written as, let's prime factorize it. 525 is 5105, 521, 3 and 7. So it is 5 into 5 into 3 into 7. And then 3000. So 3000, if prime factorized, it is 3 and 1000, and it is 5 and 200, and then it is again 5 and 40, then 5 and 8, and 8 can be written as, so it is 3 into 5 into 5 into 5. You cannot write 8, you have to write 2 into 2 into 2. Only prime factors. So 5 and 5 are common here. Then another 5 and another 5 is common there. And one more 3 is common there. So these are the common factors. And if you multiply them, you get 25 into 3, 75. Hence justified also. Now explain why the expression is a composite number. To prove something composite, you just need a factor other than the number itself and 1. And how many terms are there in the expression? There are not 4 terms. There are only 2 terms, one this term and one this term. Because the number of terms are separated by plus and minus signs, not multiplication. They are just one term here. So can I take something common out of here? Yes, I can take 7 common. What is left? 3 into 5 plus continues. What is left here? 1. Now you may solve the bracket as well because it's simpler. 5 3s are 15 and into 16. But even if it is very big and complicated, as it is, you've proved that 7 multiplied by some number will give you this expression. Right? This implies that 7 is a factor. 7 is a factor of 3 into 5 into 7 plus 7. right? Therefore, the given expression is a composite number. Can two numbers have 18 as their HCF and 380 as their LCM? Give reasons. We know the property that HCF into LCM is equals to the product of the two numbers. So the two numbers are not given to us, but HCF and LCM is given to us. Like HCF is 18 and this is 380. And we presume there will be some number here when you multiply. This implies that 380 by 18 should give you a proper whole number or a natural number, right? It should be clearly divisible. That is, 18 should be a factor of 380. But if you divide it, if you reduce it also, this is like 2 nines and this is 2 190s. This is no more further divisible. This is not giving us any clear whole number or a natural number. Therefore, it is not possible. So, can two numbers have 18 as their HCF, 380 as their LCM? No. Right? If any other type of question comes, you only have to check whether the given HCF is a factor of the given LCM. If it is a factor, yes, it is possible. If it is not a factor, it is not possible. Question number 9. Without actually performing the long division, find if 987 upon 10500 will have terminating or non-terminating decimal expansion. Yes, only the denominator factorization can help you, but there are chances if there is any common factor with the numerator. So when there is a big expression, you factorize the numerator as well. So this is divisible by 3. So 3 3s are, 2s are and 9s are. And this is divisible by 7. So this is 7 4s are and then 7 7s are. That is it. Now let's do it for the denominator. So this is 5 2 100, then 3 700, then 7 100, and 5 20, 5 4 4 and 2 2. So first we'll have to cancel out some common factors. Otherwise, just looking at the denominator can give you a wrong answer. So 10500, 987 is 3 into 7 into 47, and the denominator is there are 3 5s, this and this, then there is a 3, then there is a 7, and there is 2 raised to power 2. So if you had only factorized denominator, you would say, oh, there are 3 and 7. So it will not have a terminating decimal expansion. But 3 and 7 are getting cancelled. So in the denominator, there are only 5 and 2 left, which implies the given expression will have terminating decimal expansion. Done. Let's move to the next question. Question 10. A rational number in its decimal expansion is 327.7081. What can you say about the prime factors of q when this number is expressed in the form of p by q? Give reasons. We can easily see that the decimal expansion is ending. That means q will have factors as 2 or 5 only. The reason is that the decimal expansion is ending, right? You can even convert it into the fraction if you want to. This is upon 1 2 3 4, and this can be easily written as 2 raised to power 4 and 5 raised to power 4. Next. Exercise 1.3 now. I have again cut the questions which were according to the Euclid's division lemma, which is not in the syllabus. Prove that root 3 plus root 5 is irrational. We know root 3 plus root 5 is irrational. Sum of two irrational numbers is irrational, but they're saying it to prove it. So when we have both of them as irrational, how do we prove it? We say let it is rational, and this time root 3 plus root 5, we will make it equal to only one variable, that is a, one integer, or I can write it as a by 1 for the convenience. You can take a by b and continue the calculations, but a by 1. So now I'll transpose one of them, like root 5 is equals to a minus root 3. I'll transpose one of the irrational number, and now I'll do squaring both the sides. Squaring. So I'll get root 5 square, that is 5, and a minus root 3 square, which is actually equals to a square plus 3 minus 2a root 3. Now, irrational term minus 2a root 3 on one side and rest all on the other side. So I'll transpose 5 minus a square minus 3 is equals to minus 2a root 3, or root 3 is equals to 2 minus a square upon minus 2a. Now a, we knew that it's an integer. We already declared it to be a rational number. So now here this expression is rational, which implies root 3 should be rational. But we already know that root 3 is irrational. Therefore, our assumption was wrong. Our assumption was wrong, and root 3 plus root 5 is irrational. Whenever there is a sum of two irrational numbers, you always transpose one of them to the other side and square both sides so that you get rid of one of them, right? And the other can be proved equal to a rational number and contradiction occurs. Question 11 now. Show that 12 raised to power n cannot end with the digit 0 or 5 for any natural number n. Now, to a number to end with digit 0, it needs to have factors of 2 and 5. So 12 raised to power n, if I factorize it, I will get 2 into 2 into 3 raised to the power n. Since there are no 2 and 5, there is no 5 rather. That is why this number will not even end with 5, right? A number to end with 5 needs to have 5 as the factor. A number to end with 0 needs to have 2 and 5 both as the factor. So both the things are not compiled here. That is why 12 raised to power n will never end with 0 or 5. You can write that 5 is not as a factor. 5 is not a factor. 5 is not a factor of 12 raised to power n. Therefore, 12 raised to the power n cannot end in 0 or 5. Cannot end in 0 or 5. Question number 12. On a morning walk, 3 persons steps off together and their steps measure 40, 42 and 45. What is the minimum distance each should walk? The minimum here gives you a hint for LCM, so that each can cover the same distance in complete step. What happens here is that a first person whose step is 40 centimeter will cover the multiples of 40, like 40, 80, 120 and so on. The second person will cover the multiples of 42, 42, 84 and so on. And 45 will 45, like when he starts he's 0, then he's 45, then he's 90 and so on. So basically we are dealing with the multiples of these three. When will they be all together? When they find a common multiple. And what is the minimum? The minimum words tells you the least common multiple, that is LCM. So let's find the LCM of 40, 42 and 45. So I'm dividing by 5 first. It is 5 8s and 9s, and then I'm dividing by 2 4s, 21 and 9, then 3 7 and 3. So I've got a co-prime here. So your LCM will be 5 into 2 into 3 into 4 into 7 into 3. So this will be 10 and 30 multiplied by 28 into 3, that is 90 into 28. You may do your calculations the way you like it. It is 2520. So this is the minimum distance everybody should walk so that they are at the same distance. Question 13. Write the denominator of rational number 257 by 5000 in the form 2 raised to power m, 5 raised to power n, and also find the decimal expansion without actually dividing it. So we'll have to factorize the denominator, which is 5000. So I start with 5, it is 5000, then it is 5200, then it is 540, and 5 8, and 8 we know is 2 cube, right? So I can write 257 upon 5000 equals to 5 raised to the power 4, 257 upon 5 raised to the power 4 and 2 raised to the power 3. So we are done here. We have done the first part. Now I have to find the decimal expansion without actually dividing. So I need the power same here so that I make it 10. So I need one more 2 here. So I will multiply the numerator also with one more 2 there. So when I multiply 257 into 2, I get 4, 1 and 514 upon 5 raised to power 4, 2 raised to power 4, which makes it 10 raised to the power 4. And now it is easy. You only have to shift 4 decimal places, or I may write it 1, 2, 3, 4. And now if I shift from here, I'll get 0.0514. So without actual division, I found the decimal expansion. Question 14. Prove that root p plus root q is irrational where p and q are primes. We have done a similar question where it was root 3 and root 5. So in these questions, we again presume that let root p plus root q is rational and root p plus root q is equals to an integer a, or I may take it as a by 1 for my convenience for the calculations. You may continue with a upon b also. Now I will transpose one of them. It's your wish, you can transpose any one of them. And now I will square both the sides. Square both sides so that we get rid of one of the rational numbers. So what is this now? It is just p and it is a minus root q whole square. When you square both sides, it is the square of entire LHS, square of entire RHS. You don't do square of one term. So now a minus root q whole square will be a square plus b square minus 2ab. So there is only one irrational term left here, root q. So we will keep root q on one side and transpose all the others to the other. So I'm getting p minus a square plus q is equals to minus 2a under root q, or root q will be equals to p minus a square plus q upon minus 2a. Now this entire term is rational, which implies root q should be rational. But this is a contradiction, but root q is irrational. Therefore, our assumption was wrong and root p plus root q is irrational, hence proved. So this ends the advanced questions of chapter 1. Please press the like button, subscribe button and the bell icon. Do share it also.